Hello, everyone. This is electron configuration from periodic table and abbreviated electron configuration. Okay. Either abbreviated or noble gas electron noble gas notation. Anyway, before we start, let's review what we had in last video about electron orbital diagram and electron configuration. You must understand electron orbital diagram before you'll be able to understand this electron configuration from periodic table. If you do not understand that, this is waste of time. So I'll encourage you to go back and watch that video on electron orbital diagram. So let's look at review. It said draw electron orbital diagram and write electron configuration of the following elements. Okay, this was the last video. So before you start, if you know how to do this, pause the video and try to do it and make sure you understand it. So for those of you who maybe you didn't do it, though, I advise you to go back and watch the video on electron orbital diagram. I will briefly go over it. So we want to draw electron orbital diagram and write electron configuration for neon, cobalt, and magnesium. So hopefully you watched the last video and able to do this, draw electron orbital diagram for neon, cobalt, and magnesium. But in case you did it and you want to know, check your answer, this is how to do. So we go to neon. I'm doing it I'm doing this with simulation, okay? So the first thing you do, you go to the periodic table and check atomic number of neon. Atomic number of neon. And looking at the periodic table, atomic number of neon is 10. And the atomic number is the same as number of protons. Every element in the periodic table is neutral. All the elements you are given are neutral. Therefore, it has number of electron is 10. Okay, so we place these 10 electrons following the rules in electron orbital. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is electron orbital diagram. You start from the first energy level, and it has to be opposite spins. You then, before you go to the second energy level, when you get to p orbital, you have to put 1, 1, 1, then you pair them up. So this is electron orbital diagram, and then this is electron configuration. 1s, 2, there are 2 electrons in their first energy level, s orbital, there are 2 electrons in this orbital. Then 2s, second energy level, s orbital, there are 2 electrons. Second energy level, again, there's p orbital, there are 6 electrons. So you've done the neon. So we go to the next one, cobalt. Cobalt is right here. Okay, cobalt. Cobalt, 27 electrons. Okay, atomic number is the same as number of protons. It's a neutral atom, therefore, it's 27 electrons. So we reset. Okay, we are placing 27 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 27 electrons. Okay, this electron orbital diagram of cobalt. the electron configuration, remember in the last video, I emphasized that 4s2 has to come before 3d7. So this is not correct. This has to switch. There has to 3p6, then 4s2 before 3d7. Okay? Then we want to look at electron. Let's do the magnesium. Magnesium is this one. So 12 electrons. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So this is the electron configuration. 1s2, there are 2 electrons here. Second energy level s orbital, 2 electrons here. Then second energy level p orbital, there are 6 electrons here. Then third energy level, there are 2 electrons, 3s2. That's it. Hopefully you got it right. Before we continue, I want to emphasize things you must know, because if you don't understand it, will come up in the next discussion. Okay, and did you get confused? There are 7 periods. 1, 2, 3, 4, 5, 6, 7. There was a video we watched. Then this is 1, 2, 3, 4, 5, 6, 7, right? You choose. What's the difference between this periodic table and this? You see that this is extended periodic table. Look at here. This section is here. Okay, why is that? This is period number 6. Look at this number 58 to 71. 58 to 71. Now you have 57, 72. That means this row supposed to be here. And here you have 90 to 103. 89 to 104. That means this row supposed to fit in here. That's what you have here. You see that? So this is in period 6. This is in period 7. So some periodic tables are like this, but for convenience sake, that's why they are removed and put here, just for convenience, so that it's more convenient. That's it. Okay, this is more easier to manage than this periodic table. So generally we use this, but you have to understand that. Okay, take a picture of this if you don't have the picture. Again, if you didn't watch the last video, you wouldn't know what you're doing here clearly, okay? Just to refresh your memory. Remember, there are 7 energy levels, okay? So look at this. There are maximum of 2 electrons in s orbital, maximum of 2. This, it starts from 1s to up to 7, okay? Now, for this p orbital starts from 2p, 3p, 4p, 5p, 6p, 7p, and there are, you can have maximum of 6 electrons in each p orbital. Then for d orbital, it starts from 3d. The energy level starts from third energy level, 3d, 4d, 5d, 6d, 7d, and it has maximum of 10 electrons, right? And this starts with maximum of this starts from F4, F4 energy level, 4, F5, F6, F, and this has maximum of 14. Now, please take a picture of this, because we will see how this is used in arranging periodic table. We will use the relationship, we see the relationship between this and the periodic table. Take a picture, okay? Now, you have your picture with you while we discuss this. Now, look at this. This is, remember, S orbital has maximum of 2 electrons. So here, instead of first energy level starting from the bottom, in periodic table, it starts from the top. 1s, 2s, 3s, 4s, 5s, 6s, 7s. So we call this S block. And you see there are two squares here because of it has maximum of 2. This can contain 2 electrons, 2 electrons, 2 electrons, 2 electrons, 2 electrons, okay? Then let's go to P block. This is P block. If you look at that electron orbital diagram, the P block starts from 2p, 2p, 3p, there should be 7p, but it's not written here, okay? And then there's maximum of 6 electrons. So you have 1, 2, 3, 4, 5, 6, okay? Now, D block has maximum of 10 electrons as it starts from 3D, okay? So you see 3D, 4D, 5D, 6D, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10, because it can hold 10, maximum of 10 electrons. Then for F block, this is called F block. F block can hold maximum of 14, and it starts from 4F. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So clearly you can see the relationship between this and the electron orbital diagram. Very important. Now, another thing we looked at is in the other video, we looked at the order of these. You see, look at this, 1s. When we do electron configuration, this is helium. We normally move it to here. So it's supposed to be here, okay? We move it, so let's say use our imagination that this is crossed out, and then it is here, okay? Here, that will be 1s, okay? So look at it, 1s. If you remember this, I told you to write down the order last time. We have 1s, read it like a book, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 6s, 5d, I mean 6s, then this is supposed to be here, remember? This row is supposed to fit in here. That is 6s, 4f, okay, 5d, 6p, 7s. Remember, this part is supposed to fit in here. So that's how we come up. So you're seeing the relationship between electron orbital diagram and this, right? Now, there's more detail here. Now we see the actual elements in the periodic table. So this is, again, S block. This is D block. You see D block. Any energy level, because it starts from 3D, okay? It starts from 3D. So this is 4, but when you get here, it's 3D energy level, okay? Then this is P, okay? Now, you see here, this is very important. You see S block, NS1, NS2. This is telling the energy level. Energy level, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6, it can be 7. That's what this N means. But this is S1, S1. This is S2, D1 up to D10. Then you have P1 up to P6. That's the maximum. Remember, S block can hold maximum of 2. That's why you have here. D block, D orbital can hold maximum of 10. That's why you have this ending in 10. P can hold maximum of 6. That's why you have ending in P6. F block can hold maximum of, or F orbital can hold maximum of 14. That's why you see that F14 here. Okay? So now we want to use this to read to write electron configuration without drawing the orbital. Now we are not getting the electron configuration from orbital. Now we want to read it as a book. And as we go, we are writing the electron configuration. So let's do the example. Okay. Let's do these examples. Let's write this from periodic table. We write this from periodic table. Okay. We write this from periodic table, and then so what I have you to do is take a picture of the periodic table. Take a picture of periodic table, okay? Take a picture of this periodic table because we'll be looking at it as we do this section, as we do the examples. Okay, I want you to get a blank paper and write down what I will say. Let's start with hydrogen. Let's start with hydrogen. We want to write electron configuration from periodic table. So we start with hydrogen. As we did with the electron orbital diagram, you start from first energy level. So we will say 1s1. Hydrogen has only one electron. 1s1. Okay? Then you are done. So write down 1s1, please. Hydrogen 1s1. Then for helium, this helium in your paper, if you have it in paper, this helium should be here. So you should move helium here. Okay? It's supposed to be here in S block. Helium is in S block. So it will be the electron configuration will be 1s2. 1s2, that's it. Write it down. Helium is 1s2. Then for oxygen, oxygen is here. Okay, remember, we are doing this in order. In case you forgot the order, you remember? 1s, 2s, remember this? It's from here, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p. So it must be in this order. You can take a picture of these too, okay? Now, we've done hydrogen, we've done helium. Hydrogen is 1s1. So everything in this column or in this group ends with s1, okay? Everything here ends with s2. So helium is 1s2. Okay, now let me do lithium. Let me do several of them. I'll still do the other three from the example. So for lithium, if I want to write electron configuration from lithium, again, I'll start from first energy level. 1s, it has to be filled up because lithium has 3 electrons. You have to go 1s2. You go here, they read it at the book, then 2s1. 1s2, write it down. 2s1. Okay? Now, if I want to do electron configuration for beryllium, it will be 1s2. You start from first energy level, you fill it up. You go to second energy level, you go here. There's nothing here. You start again like a book. 2s2. Okay? 1s2, 2s2. Okay? If you want to do boron, it will be 1s2, 2s2, 2p1, 1s2, 2s2, 2p1. If it's carbon, it will be 1s2, 2s2, 2p2. Okay? If it's nitrogen, it will be 1s2, 2s2, 2p3. If it's oxygen, it will be 1s2, 2s2, 2p4. Okay? If it's fluorine, 1s2, 2s2, 2p5. If it's neon, it will be 1s2, 2s2, 2p6. Then if it's sodium, it will be 1s2, 2s2, 2p6, 3p1. Okay? If it's magnesium, 1s2, 2s2, 2p6, 3s2. Okay? If it's aluminum, it will be 1s2, 2s2, 2p6, 3s2, 3p1. If it's silicon, it will be 1s2, 2s2, 2p6, 3s2, 3p2. If it's silicon, I hope it's silicon. Did I mess up? Silicon, we end in 3p2. 3p2. Phosphorus will be 1s2, 2s2, 2p6, 3s2, 3p3. If it's sulfur, it will be 1s2, 2s2, 2p6, 3s2, 3p4. If it's chlorine, it will be 1s2, 2s2, 2p6, 3s2, 3p5 if it's chlorine. If it's argon, it will be 1s2, 2s2, 2p6, 3s2, 3p6. Okay, let's do this. What if it's iron? Let's do iron. I want you to pause the video and do it by yourself before I do it. Pause the video. If it's iron, hopefully you pause the video. So for iron, it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Remember, D block starts with 3 energy level, 3, and look at that order we did before. So I told you to write this down. I wrote some of them down for you so you can compare and see if you wrote it down correctly. Did you get this right? This is the example. Okay. Look at this and compare it with what you wrote down. And now you have practice questions. Pause the video. Pause the video and do this. So hopefully you pause the video and this is the answer. Okay. The one I just gave you now, check if you got it right. If you didn't get it right, go back to my examples and you find that this still follows the order, but you are getting this from periodic table. Okay, you must know it from periodic table. Don't skip it and try to do it like using the electron orbital diagram, because we are going to another way of doing this, which you cannot use the electron orbital diagram to do. So you must understand this first. Okay. So another way, another one is called abbreviated electron configuration or noble gas abbreviation. Okay. Or some people call it noble gas notation. I'm not sure abbreviation is the best thing here. Noble gas notation. Okay, now, the noble gas configuration system allows some shortening. That is the shortcut. This is very easy. All you have to know is understand the last one we did. This is so easy. So it allows some shortening of the total electron configuration by using the symbol for the noble gas. So you, instead of starting from 1s2 all the time, you start from noble gas. But how do you know the noble gas you're starting with? So the noble gas starts from the last noble gas electron configuration before you reach the element you are trying to write. So how do we do this? Let's look at, this is periodic table, right? This is S block. This is D block. This is P block. This is F block. Now, you are given an element like zinc. You are asked to write the electron configuration, abbreviated shorthand. Okay, what you do, you are using this in writing this electron configuration. You are using this, okay? But what I will do, I think I will demonstrate this first so that it's not confusing. Please take out your periodic table. Take out your periodic table. I want you to look at electron configuration of beryllium 1s2 2s2. Now, instead of the abbreviated electron configuration, instead of starting from 1s2, we start from helium. Why? Because we start from noble gas before beryllium. Noble gas is group 18 or group 18, okay? The noble gases, they are noble gases. Now, we can only use the noble gas in writing this abbreviated electron configuration. That's why sometimes it's called noble gas notation. Now, beryllium, the noble gas before beryllium is helium. So we put that in parentheses. That means this noble gas, this is the electron configuration of helium, this. Then after that, you continue. Then you continue to 2s2, okay? 2s2. Now, so this means 1s2, electron configuration of helium, which is 1s2. It means electron configuration of helium. That's what it means. Then for magnesium, this is the electron configuration of magnesium. And the noble gas before magnesium, it cannot be after. It has to be before, the one closest to it. So the noble gas before magnesium cannot be helium this time. The one closest to it is neon. So we will write neon. Okay? Neon. So this means 1s2, 2s2, 2p6. That's what this means. It means 1s2, 2s2, 2p6. Then, now that's abbreviated. We finish it up. Okay? Now, calcium, this is the electron configuration for calcium. Now, calcium, the noble gas before calcium is argon. Argon. Okay? Argon is 1s2, 2s2, 2p6, 3s2, 3p6. Now, so that's the abbreviated electron configuration for argon. Okay? Now, before we continue, I hope you're looking at your periodic table. Before we continue, let's look at which noble gas configuration are we supposed to use in writing for, let me show you the practice question on this. So let's do the practice question. Which noble gas do we use if you want to write abbreviated electron configuration for, or noble gas notation for beryllium? Which noble gas do we need if you want to write for silicon or for iron? Which noble gas do we need? So I would like to pause the video and have the demonstration for you. I hope you have your periodic table. Okay. So look at your periodic table. I think I've done beryllium before. So for beryllium, the noble gas we can use to write the abbreviated electron configuration will be helium. So it will be this, helium. So for silicon, found it is in period 3, group 14. The noble gas we will use to write the abbreviated for silicon will be neon. So that's it. Then for iron, the noble gas we need to use before that will be argon. I hope you got it right. You're supposed to pause the video before you do this. Okay, now, if we want to write the electron configuration, there are two things you can do. You can write all your electron configuration if you want, but it's waste of time. All you have to do is you start, instead of starting from 1s, you go and start from that particular noble gas. So we have to start from helium and then continue. It will be helium, then 2s2. You are done. Then for silicon, instead of starting from 1s2, as we normally do, we start from neon. Neon, which we have, and we continue 3s2, then 3p2. 3s2, then 3p2. Then for iron, instead of starting from 1s2, you start from argon, then you continue 4s2, 3d6. That's a tricky one. D starts from energy level 3. You see that? You're done. So now I give you one more example, then you do the practice question. So these are the answers, because all I asked here is which noble gas will you use to write the electron configuration for these elements, but we ended up writing the electron configuration. So let's look at this example. We want to write the abbreviated electron configuration for zinc, Okay, now, so zinc is here. So the noble gas we will use, remember, we can only use these elements that are called noble gases. Only this we can use in right now abbreviated electron configuration. Now, zinc, the noble gas before that is argon. We cannot use neon because we want to use the one closest to it, argon. That's how we get that. So you put this in parentheses, argon, like you see here, and you continue 4s2, 3d10. Let's review the one we did. Remember, we did beryllium. So beryllium is here. Okay, we want to write abbreviated noble gas configuration. The noble gas to use is helium. So we put helium in parentheses, helium. It will be then 2s2. We want to do magnesium. The noble gas before that is neon. We put this neon in parentheses, it will be neon, then 3s2. We want to do sulfur. It's still neon. We put neon in parentheses. We continue 3s2, 3p4. Okay, that's all. It's very easy, much easier than what we did before. So now I want you to write, do practice questions. Pause the video. Pause the video. Okay. And this is the answer. I want to get your attention. Hopefully you got this right. Helium 1s2. This one cannot be abbreviated. Okay, so it's an exception. You can write abbreviated electron configuration for noble gases. That's basically what it means. Okay, hopefully you are able to understand it. Thank you.